It loses 5 million tons every second. Sunlight is made of mass. To shine, the sun converts about 4 million tons of matter into energy every second, and that energy leaves and never comes back. Another 1.5 million tons or so blows away as the solar wind. Call it 5.5 million tons a second, gone. Written down like that, it sounds like something you would want to keep an eye on. It is not. Over the entire 4.5 billion years the sun has been shining, everything it has lost in this way adds up to a small fraction of 1% of its mass. That is the useful thing about stars. They are so large that processes which would be catastrophic anywhere else are, on their scale, a slow trickle. We know the number without weighing anything. Measure how much sunlight falls on 1 square meter at the Earth's distance. Multiply by the area of a sphere that size, and you have the total output. Divide by the speed of light squared, and you have the mass being spent. The whole calculation rests on one equation and one careful measurement of brightness. Everything else is a rounding error. Take the sun, all 8 planets, every moon, every asteroid and comet, all the dust, and weigh the lot. The sun is 99.86% of it. Everything else together, all of it, is about 1/7 of 1%, and Jupiter alone is most of that remainder. All the rocky planets, all the moons, all the ice and rubble, this planet and everything that has ever lived on it, share what is left over. That ratio explains why the solar system is stable and quiet. Nothing else has enough mass to matter. The planets tug at each other in small ways over long periods, and those tugs are measurable, but none of them are in a position to argue with the middle. It is worth sitting with the number for a moment before moving on. We speak of the solar system as a collection of worlds. By weight, it is one object, with a little debris still in orbit around it. The sun orbits something too. Gravity pulls both ways. The sun holds Jupiter, and Jupiter pulls back on the sun by exactly the same force. So they both go round a shared balance point, the way two people swinging each other around lean back against one another. That point is called the barycenter of the solar system, and it is not at the center of the sun. Jupiter is heavy enough and far enough out to drag that balance point outside the sun's own surface. Depending on where the big outer planets happen to be, the barycenter sits anywhere from near the middle of the sun to about 1 solar radius above its surface. So the sun does not sit still. It traces a slow loop, taking a couple of decades to go round, moving at a few meters a second. This is not a curiosity. It is how most planets around other stars were first found. We cannot see them, but we can see their star wobbling towards us and away from us in exactly this way. And from the size and rhythm of the wobble, we can work out what is pulling on it.